All right, problem 33 gets us into this next batch of problems here in the homework where they're asking us to use the limit definition to compute f prime of a, that's what they want to find right here, and also find the equation of the tangent line, which should be pretty easy after we get to that point. So the hard part here is going to be finding our derivative, and we're going to do this using the formula I like you guys to use for the general derivative. It is the limit as h approaches 0 of, and here we go. We begin with f of x plus h. So everywhere in the original function that there was an x, we replace it with x plus h. So that's going to give us an x plus h cubed, that'll be fun, plus another x plus h right there. And that takes care of the f of x plus h, minus, and now it's going to be f of x, just the original function, unchanged, x cubed plus x. Got it, all over h. Plug and chug will never work on these derivative limit problems. So that means we've got a lot of algebraic manipulation and hopefully simplification to do upstairs in the numerator before we can do anything else. Okay, this first part here is probably what's giving some of you guys trouble right here. X plus h quantity cubed. And this is something I was really hoping you guys would have learned over the last couple of years here. If not, let's get it written down and let's memorize this because this could come in handy. Cubing a binomial, everybody, is going to get you your first term cubed plus 3 times your first term squared times your second term, which in this case is b, just to the first power, plus another 3. Now it's going to be your first term to the first power and your second term to the second power. And lastly, just the last term, b, raised to the third power. So that's the expansion, everybody, of a plus b quantity cubed. Follow some similar patterns to a plus b squared, but obviously it's more complex than that. So doing that, here we go up on the top. We're going to have an x cubed plus a 3x squared h plus a 3xh squared, and then plus an h cubed. That was the hard part. Let's keep going now. We have a plus x and a plus h, nothing really to worry about there. And now this negative sign needs to be distributed into this next binomial. So we're going to have a minus x cubed and then a minus x all over h. Now, remember what we said before, guys. Every time you're doing this with a polynomial function, which is what we're dealing with right here, every term in the numerator that does not contain an h should cancel out. And I often find it's easier to do that from the end. I've got a negative x here at the end, which sure enough cancels with a positive x right there. I've got a negative x cubed, which cancels with a positive x cubed. And I think that's it, guys. Nothing else seems to cancel. And, importantly, every term that remains still has an h in it. So, what do we do now? We're going to factor out that h from the numerator. Pulling the one h out, that's going to leave us with a 3x squared plus a 3x times just an h, plus we now have an h squared, and then don't forget this guy right here. There was an h, we pulled the h out, we're actually dividing h by h, you end up with a 1 there, all over an h on the bottom, and as we hope to see happen, this h cancels with this h. So that means now, guys, we can actually put a 0 in for our h's here and here. And what do we end up with? We have a 3x squared. This term becomes 0. This term becomes 0. And then there's a plus 1 at the end of all that. And that, everybody, is our general expression, excuse me, for our derivative of 3x squared plus 1. Now, we're not done with this problem yet. We actually haven't found either of the things they wanted us to find. If I go back and look at my directions again, we need to find f prime of a, which is 0 in this case, and the equation of the tangent line. Okay, so let me switch colors on you right here. A couple things that we're going to need to find. First thing, everybody, your point of tangency. I could have done that right at the beginning right here. We need to find the value of f of a, which in this case is 0. So for f of 0, we'd go right back here to the original function, and that's pretty easy. 0 plus 0 is going to get us 0. So our point of tangency here is 0, 0. But now what we need is the slope of the tangent. And that comes not from the original function, but from evaluating the derivative f prime at this a value right here. So I'll just cram this in right here. F prime of 0 then is going to be 3 times 0 plus 1, we're going to end up with 1 for the slope of our tangent. So with those two pieces of information there, everybody, we're ready to go ahead and solve this problem right here. At least I think so. So we're going to go here. Boop, boop, boop. That's not what I wanted to do. There you go. We're going to go from here to point-slope form for the equation of our tangent. Y minus the y-coordinate of your point of tangency, that's 0, equals the slope of your tangent, which is 1, and then in parentheses, x minus the x-coordinate of your point of tangency, which is 0. Boy, and for all this work, we ended up with some really lame results here. The left side, y minus 0, just becomes y, and on the right side, x minus 0 is just x, times 1 is x. That, everybody, is the equation of your tangent line here. That was one of the things that they had asked for. So I guess I should make it real clear. What they wanted here was the value of f prime of a. There's the answer to the first part of the question. And then the equation of the tangent line, there's the answer to the second part. So those are the two things, those are the two things they asked us to find in this problem, and we've got them both for you. All right, so there's number 33.